Hi, so today we're gonna compare rotational motion and linear motion. As we all know, linear motion is just moving a straight line. Rotational motion is moving around a point or an axis. So what is the property characterize the rotational motion and linear motion? For rotational motion, we have inertia. For linear motion, we have mass. Mass is like a physical property for an object to resist being accelerated. What is the velocity? For rotational motion, we have angular velocity. For linear motion, we have linear velocity. And those two velocity, linear velocity and angular velocity, they have a relationship v equals to omega times r. R is the radius of the rotational motion. And the acceleration, angular acceleration is alpha. Linear acceleration is a, and a equals to alpha times r. What is the displacement? So angular displacement theta equals to similarly we have in linear motion displacement equals to so you can see these two equations, they are very, so it's just the initial velocity times time plus 1/2 times the acceleration times time square. Then what is the momentum? For rotational motion, we have angular momentum equals to, for linear motion, we have linear momentum. What is the change of the momentum? dl dt, we have torque. So torque is the reason why angular momentum is changing. For linear momentum, net force change is the reason why the linear momentum is changing. What is the energy? The energy for the rotational motion equals to 1/2 I omega square. And for linear motion, we have 1/2. So I hope from this chart, you can correlate rotational motion with linear motion. The only difference between them is rotational motion is rotating around a point or an axis with a radius r. So linear velocity equals to angular velocity times r. Linear acceleration equals to angular acceleration times r.